Alright, let's take a look at this penultimate test review for the graphing trig and stats. Alright, so these first ones are just a matching. Okay. Now, when we think about this, think of that normal curve. And we've got our mean, which they said was 80%. And you've got that first standard deviation, which they said was 7 away, so it'd be what, 73 and 87. And you've got your second standard deviation, which would be, let's see, 73 minus 7 would be 66. 87 plus 7 would be 94. And then your third standard deviation, which would be 101 and 59. Okay? So that's where we're starting with. So now it says what percentage of students were within one standard deviation of the mean. So on either side, remember we had some numbers. One standard deviation away involves 68% of the people. So that would be A. 2 standard deviations away was 95%. 3 standard deviations away was 99.7%. Okay? So, now let's take a look at number 2. What percentage of students scored less than 70%? Okay, let's hold off on that one. Number 3, what percentage of students scored greater than 80%? If 80% is the mean, that means 50% were to the right and 50% were to the left. So for that one, it'd be 50%. Okay. What percentage of students scored between 75 and 90%? And what percentage of students passed between 60% and 100%? Let's do that last one. So 60% is pretty close to that last standard deviation, right, of 59. 100% is pretty close, so it's pretty much, we could probably just round that up and consider that to be 100% of our students, right? So now we've got C and D, 8%, 69%. Okay, well, what percent of students scored between 75 and 90? 75 would be slightly a bit over from that first standard deviation. 90 is slightly over from that other standard deviation. So if you think one standard deviation is 68%, it would make sense that that one is 69%. Which would mean the last one is C, 8%. Now let's talk about it. So what percent of students scored less than 70? 70 would be right about here. Okay, this group is getting smaller and smaller, so it makes sense that it would be C, 8%. There we go on that. So it says in a normal curve, what percentage of data is found within 3 standard deviations from the mean? I believe we already answered that with the 99.7%. Okay, number 7. Now we're going to create 2. Okay, so we've got a mean of 13. So for this first one, my mean is right about there. And a standard deviation of 2. So for every 2, there's 1 standard deviation 2 away. There's 2 standard deviations and 3 standard deviations. So my curve would look something like that. Okay, now for my second one, we also have 13, but this time a standard deviation of 4. So it's going to peak at the same place, but this time its first standard deviation is going to be 4 away. Its second would be 4 more, and its last would be basically off the grid on that left side. Okay, so something like that. And then you could label each set, as the mean and standard deviations away. Often they'll label it like this if we're not really thinking about the data. So you could do it either way. Okay? So, number 8. You surveyed 50 students in your school about their favorite subject. 5 students answered math. If your school has 1,200 students, how many students would you expect to answer math if you could survey everyone? Alright, so if we're thinking about this one, a proportion is the way you want to go. Think of it like this. So we had 5 students out of 50 that gave us our desired result. Okay? And we're applying that to 1,200 students. So how many do we think would say the same thing? So we want to match up. We're making a proportion. Okay, so cross multiply. 5 times 1,200. Let me grab out a calculator. It's probably an easy number to do. What, 6,000? Yep. So 6,000 equals 50 times question mark. So we divide by 50. So 6,000 divided by 50 would give us 120. Okay, another way to think about it, 10% of those students, so 10% of those, same thing. Alright, so there's the first date. Okay, now let's take a look at our next page. The mayor wants to know how a city's obesity rate compares to the state average. So he goes to a local grocery store and asks 100 random people questions regarding their diet, height, weight, etc. Which of the following is false? False. The population is all the people in the city. Is that true? Well, his cities, so I'd imagine yes. The sample was everyone at the grocery store. Let's see. Did he ask everybody at the grocery store? Nope, only 100, so that one's probably the false. Let's double check the other two. The parameter was the obesity rate of the city. Yep, that's what he's asking about, the obesity rate. The information collected was done by a survey. He's asking them questions. Yeah, so B would be your false answer. Number 10. Your track coach wants to know if changing your diet 24 hours before you run the mile will affect how quickly you run the mile. So with a few miles already recorded, the team changes their diet and runs the mile the next day. This is an experiment, observational study, survey, or voluntary response. Okay, so think about, are they volunteering things? Probably not that one. Are they doing an experiment? Well, are they asking questions? No, so it's either observational or experiment. The difference is, an experiment, you'll have 2 groups. One having things happen, one control group. Okay, is there a control group here? No, he had everybody do it, so it's more, he's changing things, so it's more of an observational study. They're seeing how everyone is affected, not making 2 different groups and going from there. Okay, 11. Mr. Riddles wants to determine how the seating chart affects attendance. He records the attendance for each student as the year progresses. Okay, so survey, nope. Voluntary response, nope. Experiment, are there 2 groups? Nope. So once again, observational study. Number 12. The alien overlords are trying to understand human interactions. They create a questionnaire and beam it into human brains while they sleep, and they collect the results as they are filled out in the dreams. This is an observation. No, they're having people fill stuff out, albeit in their dreams. Experiment? No. A survey or voluntary response? Voluntary response? No. So yes, survey. Okay, 13. You want to know the average number of hours that high school seniors spend playing video games in your state. You randomly select 20 high schools in the state and then ask all the seniors at each of the 20 high schools about their video game habits. Which approach is this? Well, we know it's not random, and we know we're not volunteering, so it's stratified or cluster. Remember, in both of these, you put people into groups. Okay, here we've got high schools. In a stratified, you take some people from every group. In cluster, you take everyone from the groups you select. Here they're only selecting 20, but they're doing every senior. That makes it a cluster. Okay, 14. A restaurant owner wants to find out the average number of dishes ordered at each table served on Friday evenings, their busiest time. She decides to collect and analyze every 5th receipt of the night starting at 6 p.m. Which approach is this? Okay, volunteer would be having somebody outside the restaurant asking for people to talk about it, so not that. A convenience would be similar to a volunteer. Well, convenience would be more them asking. A volunteer would be more putting it on the table and letting them fill it out. That would be a volunteer. Sorry. Convenience would be somebody out there just asking people as they leave. Random would just be totally randomly picking it, whereas she has a systematic with every fifth. So, systematic. Okay, now let's take a look at the graphing. So the first two just determine the parent function. Remember, when you're just dealing with the parent function, their amplitude is 1, the period is 2 pi. If it starts at the 0, 0, like that, that is the sine. If it starts up at the highest point of the amplitude, goes down, that's the cosine. Okay. Now, amplitude period of each function. Remember, it goes like this. F of x equals a, that's your amplitude, times the sine of bx. Okay, and we use that b, you go 2 pi over b, that'll give you your period. So, we need the amplitude and the period. So amplitude is in front timesing. 17 has a minus 5, that's not your amplitude. The amplitude is the 6 outside. The period is not the 6, that's the b. So you have to go 2 pi over 6, which would be, cancel the 1, cancel the 3, b pi over 3. That would be your period. Okay, so once again, 18. It's not this minus 1 that's the amplitude, it's the 9. It's not the 3, it's 2 pi over 3, which we can just leave it like that, 2/3 pi. Okay, so it's 1/4 times, so amplitude is 1/4. It's not this 2. This 2 would be b, not the period, so 2 pi over 2. They cancel, leaving us with a period of pi. And hopefully you tried out all these problems first and now we're watching it, or at least seeing one and then stopping. Okay, on 20, amplitude would be 1/9. Period would be not 1/3. B is 1/3. So you go 2 pi over 1/3, which is basically 2 pi divided by 1/3. So you flip it to times, so 2 pi times 3 would give us a period of 6 pi. So when you have that fraction, that's what you kind of have to deal with. Okay? Alright, now graphing them. Graphing them, we use those same concepts, right? You need to find the amplitude, which is 2, the period, which is 2 pi over 2, so they cancel, which is pi, and the midline, the k, which is that plus 1. Normally the midline is here on the x-axis. Okay, so we're going to change that and bump it up 1. Okay, there's our midline. Now our amplitude is 2, and we're dealing with cosine. Think back to that parent. Here's a parent. So we're shifting everything up 1, okay, and doubling the amplitude. So this gets shifted up 1. The amplitude gets doubled, okay, and with a period of pi instead of 2 pi, we're taking it and squishing it. So the way you think about it is thinking about these 5 points, okay? So those 5 points. We start normally at the highest part of the amplitude, which was 1. We're shifting it up, and our period is 2, so I'm going to start up at 3. I'm also going to end at 3, because we end at the same place we start with cosine. But now instead of ending at 2 pi, I'm ending at pi, so I put it right there. Okay. Now, in between 0 and 2 pi is pi, that's the furthest down we go. So I'm going to go in between those. So in between 0 and pi would be pi halves. So I go 2 down, right? Because we have to, we're not doing it from this point, we're doing it from our new midline, and our amplitude is 2. So I've got to move it down, 1, 2, right there to -1. Okay. Now these 2 points that are on your midline are in between each half. So I just draw on my midline in between 0 and pi halves is pi fourths, in between pi halves and pi is 3 pi fourths. There is my new function. If I really wanted to, I could do it again within the 2 pi and make a second period. But that's all I needed to do. Okay, 22, another cosine, so it's the same idea. This time we have an amplitude of 4, so we're going even higher. Midline of 1, so we're jumping up to that 1 for our midline again. Now this 4, so we go 2 pi over 4 to find our period. That's 1, that's 2, so it's pi over 2 for our period, so it's squished even further. So you start off same way. This time, from our midline, we're going to go up 4. So starting at my midline, go 1, 2, 3, 4. So I'm going to start at 5. And we're also ending at pi halves up there at 5. Now I've got to go in the between that, so I find my middle spot. Start here, go down 4. 1, 2, 3, 4. So at that negative 3, pi fourths is where our middle point is. Oops, that wasn't a very good point. Then, halfway between, we're at the midline, so we just kind of guesstimate that. So now I've got a bunch of them. Because we've cut it down by 4, I can essentially draw 4 of these within that same period of 2 pi. Okay, but we only needed one of them. Oh, there we go. Went too far. Alright, so there we go with the cosine. Now, I think those 23 and 24 were supposed to be sine. I'm going to actually change them to sine, because I want to talk about how we graph with sine as well. And it's the same concept, but you think about the sine like this. It starts out at the midline, it ends at the midline, and directly in between is the midline. Then first we go up to the amplitude, and then down to the amplitude, and that's halfway between, halfway between. Okay? So those are the 5 points we're dealing with. So, amplitude of 4, period of, well, we've got 4 again, so that'd be pi halves, just like we already figured out down here, right? Same numbers. And then a minus 1 for our k. So my midline drops down to minus 1. I start on my midline, so we start right there. I end on my midline, but we're ending at pi halves. And straight in between, at pi fourths, is on the midline. Okay. Now, in between those two, 0 and pi fourths, is where we're going to go up. So, I go in between here, and I'm going to take it up 1, 2, 3, 4, and then for here, in between these two, I'm taking it down 1, 2, 3, 4. So up 4, and down 4. And there's our sine function. Okay? So let's do it for 24, same thing. Amplitude of 3, midline of negative 2, so we're dropping it down to negative 2. Now it's 1/4 for b, so we go, so our period is going to be 2 pi over 1/4. Basically, you get rid of the 1, and that 4 jumps up and multiplies. So that's going to be 8 pi. So that means right here at 8 pi, that's where we're going to be finishing. So I draw a point right here at my finishing, a point at my starting, go halfway between, which is going to be 4 pi, draw my middle. So starting, ending, middle. I think sine is a lot easier because of that. Then we go halfway in between. So 1, 2, 3, 4. So halfway between 0 and 4 pi is 2 pi. And that's going to climb up to my amplitude, 1, 2, 3. Then I do the same thing. Between 4 pi and 8 pi is 6 pi. But I'm going to go down 1, 2, 3. So it's at negative 5. And there is our sine function again. Alright? Okay, now on 25 and 26, I believe these are our last two, right? You're graphing these ones as well. but we're dealing with the phase shift now. So let me draw a graph here. We've got pi fourths, pi halves, 3 pi halves, 2 pi, 3 pi fourths, pi, okay, and then we'd go, so that would be pi halves, this would be 3 pi halves. Okay, so the phase shift, amplitude of 1, my b is 1, so a period of 2 pi, so we'd need to continue this out, right? Be 3 pi halves, so this would be 2 pi. Right, be 4 pi, no, that'd be 5 pi halves. Don't know why I didn't put a graph on this one for us, but it'll work. So, and our midline is the same. So essentially, here's our parent graph, 1, negative 1. It's cosine, so we start at pi, then at pi we're down low, and then at 2 pi we're ending again, right? And then at pi halves we're right here, at 3 pi halves we're here. There's our parent graph. Our graph, however, is shifted by adding pi halves to it. Okay? Now, one thing we got to remember is inside the parentheses we think opposite. So a plus pi halves really has that phase shift of a negative pi halves. So what that means here at negative pi halves is that all of these points are going to shift back a pi halves. Okay, so our new graph would start right here, go down right here, this one would shift back too, then down here, then up here. So you just shifted your whole graph back like that. Okay, that's all the phase shift is, right there. Alright, now let's do it for 26. So let me erase this. So now we're dealing with the sine, same concept here. So I draw my graph. We didn't mess with the amplitude, the period. So A is 1, period is 2 pi. Our midline is 0, so we need our phase shift. So it would be a negative 2 pi thirds. Well, what is 2 pi thirds? Okay, how much is that? What do we think of that? If we look up here, notice we don't have any thirds. Okay, when we're counting by thirds, like pi thirds, okay, that's the equivalent of 60 degrees. Okay, so we've got to think a little bit differently here, right? So we normally go so this would be pi fourths, pi halves, 3 pi fourths, 2 pi, or just 1 pi. This would make this 2 pi. This would make back here negative pi. Okay. Normally with sine we start down here, 1 and negative 1. We go up, pi back to the midline, go down at 2 pi back here. So there is our parent graph for sine with all these same things. Now we've got to jump back negative 2 pi thirds. Okay? Each one of these is like 45 degrees. And we're jumping back 60 degrees. Okay? So 60 is like 4 times 15. 45 is 3 times 15. So we're moving back 45 plus like a fourth. Okay? Well, suppose an extra 15 would be a third. Like, if we cut this into thirds, each of those would be 15 degrees. So to jump back, each of these points is going 15, 30, 45, 60. So we'd start out right here. So we're moving back a whole spot and a little bit. 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 To get our new function. Oops. Didn't do very good on this one. Yeah. Didn't like that one either. Okay, something like that. Those phase shifts are probably the toughest ones to deal with. But there we go, guys. There's your review. Good luck. Make sure you're ready for that test next week.